This video will go over 8.5 angles of elevation and depression. So our first word we have is angle of elevation. So an angle of elevation is going to be an angle formed from the ground up. When we have an angle of elevation, we are going to use as is. So in our picture, in the angle of elevation, here we have on the right side, the angle of elevation is what we're used to, okay? It starts from the ground up. So if this was 40 degrees, we would go ahead and just use the 40 degrees for our word problem. We don't really have to do any additional math or thinking there. So angle of elevation, we're just going to use the angle. If we are given angle of depression, this is going to be an angle formed from the horizontal line above. Okay, so here we have above the horizontal line, and then angle of depression means it's going down. So from the top down, it's going down, angle of depression. And so in this case, we are going to have to use alternate interior angles and then solve using the angle. So thinking back on last semester, alternate interior angles are on opposite sides of the transversal when you have parallel lines. So you have to assume that the horizontal line up here and the horizontal line down here are parallel. This is going to be our transversal. So if you're given the angle of depression, you're going to use alternate interior angles, which would be this is an alternate interior angle to this, meaning that they are congruent, and then you can go ahead and use that angle measure, okay? But you have to transfer that information using alternate interior angles before actually using it in your problem. So keep that in mind. If we're talking about an angle of depression, you're going to use alternate interior angles and then apply that to the triangle that you're going to use. So here we have just two examples so you can kind of get the hang of how to identify an angle of depression and elevation. In this case, your angle of depression, let's start with that one, would be this one. It kind of starts from the top, goes down. So my angle of depression is going to be angle. We started with the letter T, then we went towards R, ended up at Z. So that's my angle of depression. And then my angle of elevation, okay, it's the one going from the bottom, so starting at Y, going towards Z, then up to R. So angle Y, Z, R. Okay, that's the difference. So depression starting from the top goes down. Elevation starting from the bottom goes up. So again, take a moment and see if you can figure out number 2. Feel free to pause the video now. Hopefully you got angle of depression. Again, starting from the top. So we have P going towards R, down towards M. So angle P, R, M. And then the angle of elevation, starting from the bottom, then we have the letter L, goes towards M and up to R. L, M, R. Okay. Perfect. Okay, so a lot of these problems are going to be word problems, so we need to figure out what information is important and what we don't necessarily need, or if we need to do a little bit extra work. So this first word problem we have at a circus, a person in the audience is at ground level and watches the high wire routine. So this is a person at the ground level down here. A 5'6" tall acrobat is standing at the platform. So 5'6". Please note that that's being represented by 5.5 on our picture because there's 12 inches in a foot. So if our acrobat is 5'6", that's half a foot. That's why it's 5.5. So make a note of that. And so if you needed to change that to feet, that's something you would have to do on your own. Then we have the platform itself is 25 feet tall. So from her feet all the way to the ground, that's still 25 feet. Okay. How far is the audience member from the base of the platform? Okay, so we are looking for X. Here's a little X at the bottom. We're trying to figure out how far this person is to the bottom of the platform. And if the angle of elevation from the audience member's line of sight to the top of the acrobat's head is 27 degrees. So this matters because we need to use this information. We want to know to the top of the acrobat's head all the way down to the line of sight. This is an angle of elevation for 27 degrees. Okay, so you don't have to redraw the triangle, but I'm just going to redraw it so we can really see what's going on. We know we are looking for X down here. Okay, this is going to be a 27-degree angle, and I don't need to do anything with it because it's an angle of elevation, so I'm just going to use it just like it is. Now, the problem here is figuring out what goes on this side. Because we are given the angle of elevation from the sight of the audience member to the top of the head of the acrobat, we're not just going to use 25 or we're not just going to use 5.5. We have to add them together, okay? And so I'm going to be using 30.5 for the height between the base of the platform to the top of the acrobat's head. So this is the tricky part in this one, that we have to make sure we're adding up the two numbers first, okay? Now thinking about which trig function is going to work here, this is the angle that we're using. This means this is opposite and this is adjacent to it. So I should be using tangent. So I have tangent of the angle that I'm using is 27 equals opposite first, so 30.5 over adjacent is the letter X. And to solve for X, we're going to just do a cross multiplication. Remember that you can always put any number or expression over 1. That's okay. You can always do that. And then you can go ahead and cross multiply. So we have 30.5 times 1 is 30.5. And then if I cross multiply the other way, you have X times tangent, so I'm going to leave X times and then the tangent 27. And your goal here is to get X by itself, so because these are being multiplied, you would divide out the tangent to both sides. What's going to happen on the right? That's going to cancel, and I'm going to end up with X by itself. And so now this is where our calculator comes in. So if you just type 30 divided by, or 30.5 divided by tangent of 27, you are going to end up with 59.85, which rounds to 9. It doesn't necessarily say to round to a specific, it's like 8596 and so on. I'm just going to round it to one decimal place, so I'm going to go with 59.9. And this is how many feet from the base of the platform my audience member is. Okay, if you wanted to round to 60, that's okay. So if this was a multiple choice question, it just kind of depends on how many decimal places they're rounding to. Okay? So again, it might help to redraw a triangle if you need it, or you can just use the old one, but don't forget to add up the two numbers in this case because we are using the information from the top of the acrobat's head down to the point of sight for our audience member. Okay, number 4. Maria is at the top of a cliff and sees a seal in the water. So I like to draw, I know I'm going to be talking about a triangle, but let's just pretend this is a cliff and we have someone here, okay? And we see a seal down here in the water. This is my water. Okay, I know my picture is great. So the cliff is 40 feet above the water. So if I were to measure the height of my cliff, this is 40. and the angle of depression is 52. So this is where we have to draw that imaginary horizontal line because we're talking about an angle of depression. So it's going from the horizontal line down. This is 52 degrees, okay? What is the horizontal distance from the seal to the cliff to the nearest foot? So essentially we want to find this distance here. How far is the seal? This star is my seal. To the cliff, the horizontal distance. So we're looking for x. Now, because we're talking about angle of depression, this is where you're going to be using alternate interior angles, okay? So the alternate interior angle to this one, remember it's on the opposite side of the transversal. You're treating this as your transversal. So you're going to go to the other side right there, and this is also going to be 52 degrees. So once you transfer that, you don't need to use this anymore. Okay, you're just focusing on what's inside the triangle that you created with all the different pieces. So if I look, I have my opposite, and I am looking for my adjacent, so O and A. It looks like we're going to be using tangent again. So I have tangent of my 52 degrees equals opposite 40 over adjacent is x. We're using TOA. Remember, you can always put any expression or whole number over 1, and this will help in our cross multiplication. So if I cross multiply, doesn't matter which way you start, tangent of 52 times x, you can just leave as tangent 52 times x. And then doing the other side, 1 times 40 is 40. Your goal is to solve for x, and because these are being multiplied, you will be dividing both sides by tangent. So we end up with x equals, and we don't have to rewrite this. You can just go straight into the calculator answer. But when you do put this in the calculator, you should end up with x equals 31.25. So again, if it doesn't specify what to round it to, you can just go with 31 feet or 31.3. If it's multiple choice, just pick the one that's rounded correctly. Let's just go with 31 feet. And this is the distance from the seal to the cliff. Oh, it does say to the nearest foot. So yes, we're going to round to 31 feet in this case. Okay? Perfect. So that's how far the seal is from the bottom of the cliff. Going on to number 5. Here we have Lisa is in a hot air balloon 30 feet from the ground. So hot air balloon. And okay, that looks like light bulb, but that's okay. So the hot air balloon is 30 feet from the ground. And we're assuming the ground is perpendicular, so there it is. She sees the landing spot at an angle of depression of 34 degrees. So again, here's my imaginary horizontal line. We're talking about an angle of depression because it's going to go down. And that angle of depression is 34 degrees. So we're going to assume the landing spot ends up being here. Okay. What is the horizontal distance between the hot air balloon and the landing spot? So horizontal distance, we are looking for this right here. Okay. And because, again, it is the angle of depression, we're going to transfer this angle down to here. So if that angle was 34 degrees, this is also going to be 34 degrees. The triangle I have created has opposite, and it also has my adjacent is what I'm looking for. So once again, we are using tangent. So TOA, TOA, tangent of 34 degrees equals my opposite, which is 30, over my adjacent, which is x. And again, I can put this over 1 before I cross multiply. So multiply x times tangent and then 1 times 30. These are being multiplied, so the opposite of multiplication is division. Divide both sides by tangent of 34. And in this case, it is asking me for the nearest foot. So when you put in 30 divided by tangent of 34, make sure you are rounding appropriately. In this case, I'm just going to keep it as 44 feet. Please make sure you are actually putting this in the calculator so you get some practice. Okay, last one. Okay, so we have Vernon is at the top of the deck of a cruise ship and observes 2 dolphins following each other directly away from the ship in a straight line. So here is the cruise ship and somebody's watching them from up here. And here's 2 dolphins. Okay, they're following each other on a straight line. Perfect. Vernon's position is 154 meters above sea level. This is what the 154 represents up here. Cool. And the angle of depression to the 2 dolphins are 35 and 36. So because the dolphins are obviously like one behind the other, there has to be 2 angles of depression, okay? The 35-degree angle of depression goes to this line. So that means that this corresponds to a 35-degree angle of depression or elevation if we're using alternate interior angles. The second angle of depression is 36. Okay, so when we transfer that to the alternate, using alternate interior, that means this is going to be 36. So be careful that we're following the line and we're transferring that information correctly. Find the distance between the 2 dolphins. Okay, so we are actually going to split this up into 2 separate problems. We have to look at this triangle, okay, figure out what this distance is, and then we're going to find this triangle, the bigger one. And essentially, you're going to subtract the distance from here to here, okay? So if you find the whole distance of this one and then take away the whole distance of this one, then you're going to end up with the gap that we are looking for. So let me clear this, and we're just going to take it one triangle at a time. Let's start with the 35-degree angle. So if I transfer the information, right, we said this is going to be 35, so I'm going to draw another triangle. The height, the distance between the sea level and where the dolphins are, this is still going to stay the same, 154. We're still going to look for this distance, and I'm going to use the 35 degrees here first, okay? So this is me finding JL. I'm drawing a new triangle, and this is JL. The whole distance, this is going to find the distance to the further dolphin, further to the left. So setting this up, I do have the opposite, and this is my adjacent, right, because I'm using this angle as a reference. So I have opposite and adjacent. That means I'm using tangent. So I have tangent of 35 degrees equals opposite is 154, and adjacent is x. And again, I can put that over 1. Start with your cross multiplication. I end up with x times tangent of 35. And again, it doesn't matter if you ended up putting the tangent first and then the x. And then 1 times 154 is just 154. To solve for x, we do the opposite of multiplication, which means we are going to divide both sides by tangent, 35. Okay, and when I go ahead and solve for x, so typing 154 divided by tangent of 35, get 219 point, I'm just going to go with 93 for now, okay? So what we just found, we're talking about JL, is the distance from here to here is 219.93. Okay, so that's the first part. Now I'm going to look at the smaller triangle, and in this smaller triangle I am using 36, okay? Because 36 was my angle of depression up to that orange line that I'm now doing in black. And so we have to transfer that, which means this angle is 36, not 35. So new triangle, I'll do it down here. Again, the 154 is going to stay the same. We still have a right triangle here. This time my angle is 36 instead of 35. And I'm still looking for this, because now I want to find, let me clear my picture a little bit here. Now my goal is to find this distance because I'm using the smaller triangle. Okay, cool. So looking at what I have, this is my angle. So I do have opposite, and I am looking for adjacent. So once again, you are using tangent. Tangent of your angle, 36, opposite over adjacent, and you can put the tangent over 1 so that you can cross multiply. So x times tangent of 36 is equal to 154. And then we can divide both sides by tangent because they were originally being multiplied, and the opposite of multiplication is division. So take a moment to type that in, 154 divided by tangent of 36. And x comes out to be 211.96. Okay, so it does want us to round to the nearest meter, but I want to show you what we just found. So the distance from here, the front dolphin, to the base is 211.96. Okay, so the whole thing was 219.93, and then the shorter one is 211.96. So now our very last step is to find the difference between the two. So we're going to take the 219.93 and we're going to subtract the 211.96, and we are going to round to the nearest meter. So this one is going to round to 8. So there's 8 meters between dolphins. That's what we were looking for. Okay, and that is our final answer. That's the end of this video.